Hello, everyone. My name is Ben. I'm here today to talk to you about tackling the mighty PDF. So we'll start with a little bit of context about the PDF, and then we'll get into some code stuff. Talk about the challenges of working with PDFs and some of the challenges that we faced. And then I'll demo some things that hopefully make working with PDFs a lot easier. So, co-founder, CTO of Anvil. A little bit of background. I have been a developer for a long time. Previous to Anvil, I worked at GitHub on the Atom editor. And before that, I founded a design tool startup. So let's get started. So the PDF kind of needs no introduction, but I want to give like a little bit of context before we dive into the code things. So you've done this before. You've had an email from somebody that with a PDF that's asking for like all of your most personal information. And so then you filled it out with like a random app and you emailed it back and you weren't sure exactly where your data was going to end up. So I know probably not a lot of people like doing this. I sure don't. But it's super common. Turns out most email attachments are PDFs. Like most non-cat picture email attachment are PDFs. And they're everywhere. If you had to guess how many PDFs were out there, what would you guess? Let's say, would you say like a billion, haha. Would that be exaggerating? Turns out that there's 2.5 trillion PDFs. That's not necessarily unique PDFs, but it's a lot of PDFs. There's 20 billion PDFs just in Dropbox. So there are some really good uses of PDFs aside from forms. So like resumes, ebooks, house plans. We submitted these talk slides via PDF, academic papers. And one of my favorite uses that I just learned about is fashion specs. So all of these have a couple things in common. So what do they have in common? They are all for consumption and sharing. So PDFs are really good at for things that you don't need to edit. You're not editing the PDF. You're not filling something out in the PDF. All you're doing is you're reading them. So I think we can say that PDFs are really good for screens and for printers. And this makes a lot of sense because this is what PDFs were originally built for. They were built to display information exactly the same across all devices and also be shareable. So that way you can send your underwear PDF to the underwear factory and get them made exactly like you want them to be, because you don't have to worry about them having the font or not. It'll look exactly the same as you in exactly the way that you intended. So, but the most common way that people have interacted with PDFs, certainly for me, is by filling out PDF forms. But PDF forms are really annoying for a couple of reasons. One is that there's a lot of repetition. So you have to fill out your name 6 times or fill out several PDFs with the exact same information. There's also a lot of PDFs that have logic. So you have to read and understand part of this PDF and then make decisions about like your situation. So this is a 401k tax form. So if you want to take money out of your 401k, there are tax implications, but it depends on your situation. So this is obviously hyper complicated, right? It turns out that humans are really bad at this. They're really bad at filling out PDFs. So a professional data entry person's error rate is 4%, but I know that my error rate is a lot higher unless I'm really, really paying attention. And we've heard from our customers and potential customers that their customers make a lot of mistakes filling out PDFs. So PDFs are really good for screens and for printers, but maybe not so great for humans. Because filling out these forms is pretty cumbersome. Okay, so what would be better than having humans do it? I mean, like, why are we all here? Computers obviously would be a lot better than having a human fill it out. So computers are really good at logic and repetition. So it makes sense that that they could sort of make these decisions. We could ask the user, what's your name and your birth date and your address, and then we can basically, with a couple of pieces of information, fill out all of those, check all those boxes and fill out the right fields. So this is what we want. We don't want people to be interacting with these forms. So how do we abstract away the PDF? We can't get rid of the PDF because there's 2.5 billion of them, and behavior change is really hard. But I think that we can make it so that no human has to deal with PDFs. All right, so I guess the question is, how do we interact with PDFs as developers? Do we go and read the spec? Probably not. I don't think anyone's going to do that. I certainly haven't read all of the spec or the HTML spec, and I write a fair amount of HTML. So it's huge, it's complicated. What do we do? We go we go and we find a library on the internet. So when we were starting Anvil, this is exactly what we did. Is we went to the internet and we're like, PDF filling libraries. And what we learned is that developer attention to a technology is important. So some technologies have a lot of attention from developers. So take like web technologies. It was created sort of for the same reasons as a PDF, for display and consumption and that kind of thing, for sharing academic papers. But since then, it's had like insane developer adoption. There's literally millions of developers building things like for the web, on the web. They're building libraries. There's people complaining in issues. There's people fixing those bugs. And what all of this collaboration results in is a bunch of really well-maintained high-level libraries. They have good docs. They're updated all the time. And so in this world, you're never interacting with the DOM APIs. You're interacting with like React and Sass and TypeScript and all of these cool technologies that people have built on top of web tech. So as a developer, I've become super accustomed to this kind of thing. Like I got a problem, I can go to GitHub and I can find a library that does mostly what I want. But PDF tech isn't really there yet. Compared to web development, there's very few developers looking at it. So like every human has to deal with PDFs, but there aren't so many developers looking at this. All right, there are libraries though, and they generally fall into two categories. They're complete or incomplete. And so the complete libraries can do everything that you would maybe want to do with a PDF. You can read them, you can write them, you can update them. And on the incomplete side, they usually just do like one tiny thing. And often these incomplete libraries aren't well maintained. They haven't been touched in 5 years. You can also run headless Chrome to generate PDFs, but you can't, update a PDF with Chrome. So the complete side seems really good, right? This is the route that we went down. But like the DOM APIs, they're pretty low level, like the DOM APIs. So you have to know a lot about the PDF and how it's put together to read, edit, create them. So if you're, say, want to do something simple or something seemingly simple like creating an invoice, that can lead to like a lot of overhead to set a whole thing up to like create this invoice. Okay. So now kind of into the code part of things. If we are working with low-level APIs, we have to know a lot about these PDF details. What are some of the challenges? So I'll take you through some of the challenges that we faced when we were building out our PDF service. And so these are some of like the smaller challenges. So number one is layout. So if you want to create a new PDF or you want to like add something to a PDF, you have to deal with layout. Everything in a PDF is absolutely positioned, fixed sizing, and there's no text wrapping. So there's not a lot of niceties for a content creator. So this logic that would wrap things and whatever is like pushed up to the sort of application layer. So coming from HTML, this might be a little weird. HTML is declarative. So this is like, here's what we want to display. And then the browser will make decisions based on that. It will be like, well, how wide is the screen? Like, let me shrink it down and wrap stuff. You can also give the browser guidelines with CSS by saying, okay, I want to use Flexbox and I want this column to be this wide. But the browser might ignore you, right? The browser is making these decisions on how to display things. So the PDF is opposite that, where you are specifying exactly how to draw the document. There's a bunch of little drawing commands in here saying, okay, I want to start text. I want to pick this font. I want to move the cursor here, and then I want to paint the text, from that cursor position. So HTML will automatically wrap stuff, but if we want to do that, we have to split up the lines manually. So here's an example where we did that. You measure the box, the bounding box, and then you measure each character, and then you figure out how many words will fit into that, and you break it into lines, and then you have to paint all the lines yourself. So this was a challenge for us. There are some libraries that you can put on top of those other libraries, but it was a challenge. So the second thing I want to talk about was fonts. It seems like it should be really simple, but with PDF they're not. And I think one of the reasons is because PDFs are supposed to be self-contained, and they weren't really built to be edited. So there's no fallback fonts. The font glyphs, like the specific characters to render that in that font, to render a character in that font, is embedded inside of the PDF. And you can't mix fonts in a text block. You can't say like, here's a sentence, bold this word. You have to like draw those things independently. So in HTML, going back to that, this is a lot simpler, right? Like you just specify a whole bunch of fonts and the browser will figure it out. And if we use a character that our font doesn't support, the browser will find a font that does have that character and display it. So it's magic. Fonts in a PDF are a little bit more complicated. So there's a lot going on in this slide. First of all, I picked this font called Noto from Google, and it doesn't have the she character, so I can't use it. It won't render in the PDF. And the second thing is that I'm drawing the regular and the bold word independently. And on the right there, we're embedding all of the glyphs for that specific, for those specific words. So from the regular, we're getting the HELO, and then from the bold, we're getting all of the world characters. So if we were to say use a lowercase h, then it wouldn't display because this PDF doesn't have that font. And so if you're generating a new PDF, you have to be really careful about what characters are coming in because it like has to be in the font. So that was a challenge. The next thing is rotations. So you look at this and you're like, it seems fine, right? Seems fine, but then you go to print it and it's rotated. Okay, cool. So this happens a lot with scan documents. They'll scan them upside down, and then something in the scanner software will set a rotation on the pages to be 180. So it looks to the user like it's not rotated, but under the hood it is. And so this is hard because if you want to read the coordinates of something, or you want to add something back into the PDF, you need to sort of back out all of these rotations and figure out like what exactly is happening so that you can orient your thing that way so that it looks right to the user. And so like you have to know if there's rotations on the page. There's this thing called a content stream. It can be rotated. There can be rotations on form fields. And so this was a challenge to sort of work out like, okay, we're going to add this thing into a content stream. How's the page? How's the content stream? And then we have to sort of orient our coordinate system to match that. Okay, so that's just a couple of the sort of challenges that we ran into. there's a whole bunch of other things that were hard as well. Like dealing with forms can be complicated depending on how you want to interact with them. Signatures are like their own talk. They're crazy town. And then extracting content can also be hard because of the absolute positioning. So the last line on a page could actually be first in the file. So extracting content can be difficult. There's a whole bunch of other things too that can be hard. So, all right. So we've established that PDFs are good for screens and printers. Not so great for humans because it's cumbersome, error-prone to fill out PDFs, fill out forms. And it's also pretty hard for developers to set up and maintain something, even for like simple use cases. So we're like, could we fix this? If a computer fills out a PDF, then the filled PDF is just consumable. It's no different than, say, an ebook or a resume or something like that. It's just a piece of information that you can reference later. So then it becomes good for humans. So the last piece of this then is trying to make it so that developers can fill out all these PDFs so that humans don't have to deal with it. And so that's what we've been working on. We've been working on, and we released recently, is this PDF API that does e-signatures, PDF filling, and PDF generation with Markdown right now. So our goal is to make these things super easy to use. Okay, so now I'll get into the demo. Hopefully we're all good. Let me see. Okay, I hope everyone can see that. So I'm going to take you through the 3 different things that we do. So we have a generate PDF. What we're going to do is we're going to generate a brand new PDF. We're going to generate this invoice. And so we are able to send a JSON payload to a single endpoint, and it will respond with the PDF bytes. So we're going to be using our Node client, which is just for auth help. It has some authentication helpers, and then also some helpers for actually calling the endpoints. We're going to build up our data here, and then all we're going to do is we create the client and send, and then generate the PDF with our data. So each one of these objects is a section on the PDF, and they're separated by a little bit of padding here. And they support Markdown, and then we have some helpers for creating tables because that's a common use case. So this thing's already generated, so I'll show you a little bit. So we'll add some more stuff here. We'll bold ipsum. We will capitalize this thing. Let's make this left aligned. All right, sweet. So, and then we generate it and it magically works. And so we just automatically get Markdown support here and table support and all that. So that's it for generating APIs. Okay, so moving on to the filling APIs, it's similar to the generate API, except that we have a template. So we have like an existing, we have an existing template that we have already created and uploaded into our system. And the boxes were found when we uploaded it. We did, and so each one of these boxes has an ID on it. So we are able to send data to each one of these IDs, and it will fill out the template. So we're going to generate this W4. I'll pick the other terminal. Okay, so this thing works really similar to the, first I'll generate, how about that? All right, cool. So we got it, we filled it out, awesome. It works really similar to the generation endpoint, where we just have a payload of data, and then we create the client and we send the payload with the template ID to the system, and it responds with the PDF bytes. We save it to disk, and that's it. So it's pretty simple to add new things. So we'll go over here and we'll add a box here, and we'll call this things. Now that we've done that, we have a new things. It supports this new box. So then we can go in here, we can add this anywhere. We generate it. It jumps for always. Okay, so then it worked. Cool. So that's the filling piece. And you have some options here to set up text color and font size and all that. And so the last thing that I wanted to talk about was the signature packet. So this is a little bit more complicated than the last two because there's just a lot more going on. So this example, what we're going to do is we're going to create a packet for onboarding a new employee. So an employee needs to fill out this W-4, and then we're going to have them. We're going to have an NDA generated for them, and then we're going to have them sign. The employee is going to sign both documents, and the employer is going to sign one document. So 2 PDFs, 2 signers. So first thing we do is we set up the email addresses. Now, for purposes of this example and simplicity, Anvil is going to handle the signing process. It will send out emails to all of the signers when it's their turn to sign, but that's totally configurable. So you can set up a packet where everything is handled in your application. So it's embedded into your application. We don't send your users any emails. Okay, so but we're going to use the email setup. So we set up the emails, set up the names. This works semi-similar to the other ones in that it's just one endpoint. So this is a GraphQL endpoint. We're going to call a mutation with a bunch of variables to set up the packet, and it's going to respond with some packet information. So in the variables, we set up the files. We want to use our PDF or our W4. We want to upload a new NDA, and we're going to draw the boxes. And then we specify the data that we want to go onto each one of these files. So that's the W4 one. Here's the NDA one. And then we set up the signers as well. So that just says like which files, who signs which files. Okay, cool. So we are going to go to this other terminal first, and then we're going to create the edge packet. All right. So we get this little URL here that it's the details URL. So this is a URL for this is the details URL for our new packet. So you can go onto your dashboard and you can see the status of the packet and see who's signed and who hasn't and when and all those things. So also I should have an email to sign these documents. So Sally is the employee. So I'm going to go through and I'm going to sign. Accept my signature. Start signing. And so you can see that all of this data has been filled. So the W4 has been filled with the data that we specified, and the NDA has been filled with the data that we specified. So all we need to do is then sign this, and it's waiting then for the employer. So we got a new email. So this is the employer side of things. And then we can see all of the signatures. So we can see Sally's signature here, and then we can see Sally's signature there. We sign it, and it's all done. So that everyone gets a completed email. And also we can see it on the dashboard. Okay, great. That's all. If there's any question.